I'm going to cover a few different things today. What is in the abstract, but also a few other interesting projects that I and others are working on. So I'll talk about one of the first projects with edge computing, basically putting LLMs out at the point where they're actually being used. I'll talk about some systems for collaboration between people and LLMs. And then I'll finish up with a little more speculative work that I've been working on recently on LLMs, using them to basically enhance scientific discovery. So the first thing is something called Clara. And the motivating question behind Clara was how far can we push LLM-based performance on an inexpensive voice-only system with no connectivity in a clinical setting? So cheap and at the edge. So why it matters. No connectivity. If it's all computing at the bedside, it's not drawing anything from cloud. It's much more low resource usage. No connectivity also means, and this is a big motivating factor, that PHI is all self-contained. It's there in the room and nowhere else. Low latency is by design, so it's got to be interactive. It's got to be something that the physician can actually talk to. And low cost means much more closer to equity and accessibility for future projects. And that's one of the things that we've been looking at too is, sure, we can do it here at Michigan Medicine, but what if you go somewhere where there isn't a cloud? Could you, how much can you do with that edge? So the objectives for Clara were, as I said, edge LLMs, exploring the limits of low-cost edge computing and clinical decision. Voice only, there is no screen. So exploring the limits of voice-only usage in a real-world clinical setting. So that involves not just a conversation, but a conversation in a potentially very noisy atmosphere. Collaborative clinical decision systems, establishing some parameters for what it means to have multi-physician usage, meaning if you've got a patient, you've got multiple physicians, they're talking one device, how do we coordinate that? What's that look like? What kind of problems do we encounter? And then again, like I said, privacy by design. So this is a system that sits at the bedside. So it is secure, it is gated access, so no PHI leaves the room. And by gated, I mean there are at least 2 to 3 steps to be able to talk to the system at all. So a patient can't, by design, talk to the system. A physician can, but a physician has to be pre-registered, and I'll show you how that works. So the hardware is a Raspberry Pi, 16 gigs of RAM, quad-core ARM, 1 terabyte solid-state drive, and it's running about a 4 billion parameter model, but it is quantized. So for those who aren't familiar with quantized, it basically means all the parameters for the LLM are basically 4 bits. So you take a large model, but you're limiting to the 4 bits. So you have all the parameters, but they're much lower resolution. Whisper speech recognition. So when you're talking to it, that's how it's recognizing, and hypertext to speech model for it to speak to you. Details, Jabra multi-directional speakerphone, Blue Charm Bluetooth. This is for identification of the physician. And then a pixel ring, basically to provide some visual feedback to the system. So you can tell whether it's paying attention to you and whether it's speaking to it. So this kind of summarizes the whole system. We've got a physician bedside talking. The physician is identified by Bluetooth that is on them. Also, voice recognition is employed. So the system knows who's in the room, but until you identify yourself by speaking to the system, you're actually a confirmed user of the system. Once you are, then you can ask that Bluetooth not only identifies who you are, but what is your context? Meaning, are you an emergency doctor? Are you a cardiologist? Are you some other consulting physician? So in some sense, it's identifying you also by who you are. Therefore, the language model can narrow its scope and decide what part of its repertoire of documents is it going to use to talk to it. So again, like I said, voice only, less than $100 at the time that I bought it. Self-contained everything, and it's using a RAG, retrieval augmented generation. For those who don't know what that is, It is basically just a way of collecting information, indexing it, making it readily available. And it's not just for the information, it's also a way to steer language models into a much more predictable behavior. So lowering the chances of hallucination and basically focusing it on what the task at hand is. And in this case, it's assisting a physician who may have questions. I think that about covers it. Like I said, no internet and patient privacy is preserved. So the findings with the initial prototypes are that the authentication, security are good, voice recognition, Bluetooth detection, that all works pretty well. Voice control using LLM is acceptable. I think the current throughput is about 7 tokens per second. That's really at the hairy edge of what you need to carry on an interactive conversation. That's adequate. But part of the problem now is looking up information in the RAG is really limited by what the LLM can do. So although it can pull in enough information using the context, sorting through it and ranking it and deciding what to use in its response is really limited by the computing power. So you can get a good bit of information that is focused, but sorting through that and then composing a reply is really pretty much beyond what this throughput is. So next steps really are to optimize this conversation. There's some tricks to basically have it respond in a much more fluid way, least of which is just basically streaming. So rather than compose an answer and then answer, we are actually streaming. So as the language model is or composing, it's going in real time to the text to speech. Optimizing the RAG retrieval, like I said, right now ranking is pretty limited to maybe 2 or 3 best returns from the RAG. Noisy environments, we have not really tested it in a noisy environment. I'm working with physicians right now to try and set up a test bed. And patient context RAG for physician collaboration. Like I said, the system can, in principle, handle multiple physicians talking to the system at the same time. But how do we organize that information? So if you have one physician comes in, makes some notes to the system, basically saying, I'm seeing a patient today who is complaining of chest pain. Okay, now that's a point of fact that's stored in the system. The next physician comes in, maybe it's the cardiologist following up for a consult. Anything that the previous physician found should be available as part of a conversation. So that's not technically part of the static RAG, part of what the information is for the physicians. It's part of the patient's context. So making that available in a ready format so that we can compose reasonable answers. And then I think it's probably a foregone conclusion we've got to move up to at least a single GPU to up the token count so we can get both better language as well as better retrieval and composition of replies. So, yeah, sure.
I'm wondering kind of like what the range of voices were tested here in the voice recognition system. I was wondering if, like, for example, people that speak non-standard English, have like at least as good performance.
Yeah, so the short answer is it hasn't been tested in any systematic way. We're really leaning upon the Whisper model for that. So that's a good question. I think I'd have to go to the Whisper model and see what kind of testing they've done in terms of, like you said, there's standard, and then once you get out of the distribution, people that are speaking at either end of the distribution, speaking English, but maybe not as clearly or with a different accent or whatever. So, but no, it's a good testing point to look at. Thanks. So now I'm going to move to something else. This is LLMs and as collaborators. I think this is actually what got me invited here, was the paper that I had written about a year ago, talking about a system called Limerick. So the motivating question here is, how can note-taking serve as the cognitive interface where human insight and LLM reasoning converge for synthesis, discovery, and problem solving? And that's a fancy way of saying, if I'm taking notes and I'm thinking about problems, how can I integrate a language model into my process? So rather than going out, asking a question, getting an answer, and then going back and taking my notes, is there a better way to improve that flow so that So it's a much more assistive, collaborative type of relationship. So the two projects I'll outline here are aimed at that. So why it matters? I think amplifying cognition by turning passive notes into active reasoning. So I make my notes, I may go away, I come back and I reassess, I summarize, I say, okay, I need more information about this. If that becomes something much more active where the language model can assist me, then that makes what I do naturally easier to do, more efficient. And hopefully that accelerates discovery by servicing patterns, making connections, and broadening and enriching my perspective. So think of it as having somebody who can read your notes behind you saying, have you connected it to this note that you wrote, 5 months ago? Or have you connected to this paper, which I just found, which seems to be similar to what you're asking about? Yeah, sure.
That could get really noisy,
It
At
could.
what point do you have enough information in your notes that it can provide useful?
Right. So making it run parallel to you would probably be not a good idea because you're right.
Doctor already content is much harder.
Yeah, right. If I'm trying to concentrate, I'm trying to focus my thoughts on something, having it jump in and say, "Hey, I just found this connection. I just found this paper." That's like the worst version of someone trying to help you. So the systems as designed so far tend to be you have to prompt the system to do something, to assist you, to organize or search. And so far, for me at least, that works. I for the reason you outlined it, I don't really want it jumping in and saying, I've got a better way to look at that. All right. No, you're supposed to be helping me. It's a partnership, but so sure.
Is there any literature on LLMs that have been optimized for differential diagnosis?
It's a good question. I know it's been researched a lot, and I'm sure there's quite a good literature on it. I don't know if there's been any optimization training. Don't know.
Yeah, no, I guess the only reason I ask is because I think one of the specialties of a doctor is like differential diagnosis, and so it's like, but I don't think the public knows that, if that makes sense. So.
Yeah, and it's something I'm a computer scientist engineer. I work with physicians. I admire what they do, but I'm not a physician. I'm not a doctor. I'm lucky if I can understand all the different words that they use most of the time. So, or worse, if I recognize a word and I'm using it wrong because I'm using it in a layman's term and not a specialist. So, yeah, so no, that's a good point or a good question. So the other thing that I like about the system and it's helpful for me is traceability of the insights that can evolve. So again, this idea that I don't just take notes, put them away and never look at them again. I want my thought to evolve with my note taking. I want to be able to connect my thoughts today with the idea I had last month or the way I was looking at it and see how's it changed, how's it different. And embedding the LLM in my note taking helps me with that, or at least gives me the ability to trace that. So Limerick is the language model research assistant collaborator software that is out and available on the GitHub site along with the paper. I'll give you a quick overview of this. References are available, and I can certainly provide them for anybody who's interested. Limerick principally was an aid to searching PubMed, collecting documents, and collecting them into domains. And when I say domains, it basically is a constructed on-the-fly RAG. So if I start a search and I say, I want to know something about sepsis and the current state of what the mechanics of that is from a biological standpoint, I can do a search. It'll go out, collect information from PubMed and collect that into and then compose embeddings so that I can then search more. So that was one of the principal uses for it. And the second kind of innovation for this particular project was to expose experimental data as a RAG through a RAG interface too. So if I do, I'm bioinformatician by training. So if I do differential gene expression and I have all my big tables of genes listed by how much they've changed and the confidence for those, I want to be able to ask a question about that data. and I want to be able to ask it in the context potentially of a disease I'm investigating. So if I'm looking at endometrial cancer and I've done a differential expression between someone with cancer and a normal, and I say, okay, well, what's the difference in this gene that I think is related to a particular protein? I can ask that question. I can actually look at the results, have it look at the results, and answer in context, not just generally about that gene, but in my particular results. So that's built into Limerick, and then as part of that, it supports custom functions. So I can write a new function to access any data. So, and then that's incorporated into the flow of questions to and from Limerick. So this is I'm not sure how, yeah, we'll see it pretty much. So it is set up as a web interface. And you can ask questions down here and replies come up here. And you can see in this case, we've got genes and their differential expression fold changes are coming back. And I just hit that. So we'll go to the next slide. But anyway, and you can save queries and then also search within the queries themselves. So key features then are transparently collecting domain knowledge into these domain RAGs. And it elevates experimental data as a first class RAG data available for prompt query again. So you can ask questions both of the language model, of the documents, and of the experimental data. And the other modest improvement too was to use a two-step prompt that basically went out to the RAG, pulled in the information necessary to answer a question, and then prior to composing the answer, basically optimized or ranked those responses by their usefulness a priori for answering the question. So, and that was that ranking basically improved the quality of the return. And that's what this diagram is basically showing. It's a little confusing, but what we're interested in is this is Limerick on the bottom, and this is comparing it to, at the time, BioGPT, GPT-3, GPT-4, Llama 2, and Palm 2. So anything above the diagonal into the blue basically means on a scale of 1 to 10, how did it answer a question? So each dot represents a biological question. And the complexity of the question is roughly the size of the dot. And then you grade pairwise. So basically you're comparing Limerick's performance to BioGPT's performance in answering these roughly 20 questions. So anything above would indicate that it's getting a higher score for Limerick. Anything below the diagonal would indicate that, in this case, BioGPT answered it. So the takeaway is that in general, with the exception of GPT-4 at the time, it was outperforming in terms of the quality of the answer based on what it's using for its domain knowledge. So that was an encouraging finding. So that was Limerick. It had some limitations. It's minimally context sensitive for multi-part queries. So although it could answer a single question well, which is basically a one shot, go out to the RAG, get your information, compose an answer, it was not very good at sequential thinking. So if you ask a multi-part question that says, if this is true, do query, then what happens with this? What can I conclude? So anything that had involved multiple steps, not very good at. And that was a consequence both of the design and of the fact that at the time this was using GPT-3. So no support for cross-domain queries. So like I said, although you're creating RAG domains on the fly, there's no real ability to say, give me information about sepsis and how it compares to immune response or immune models if those are two different domains. If I collect them in a single domain, then I can ask questions. But cross-domain, no support. Related to the context sensitivity is linear reasoning only. So it really had to, if you asked a question, it had to basically answer the first thing, then the second thing, then the third thing. It really had no ability to do conditional reasoning on multi-part questions. So improving on that was some recent work called Renga. Renga basically is moving from a web interface to a note interface. So like I said, the grand project is to basically help me and others with the notes I take when I'm doing scientific investigations and incorporating the language model into that. So making much more collaborative human AI scientific workflow. So one of the major additions was to include case-based reasoning. So basically templates for solving different types of problems in a kind of a schematic way, and using that to guide answers. Tools for manipulating notes, LLM prompting and reasoning. So incorporating not just the ability to answer questions, but to, at a meta level, manipulate information, notes. And then key to all of that is that from Renga's point of view, everything is a note. So user notes, case-based reasoning notes, so the templates for reasoning, and the tools themselves. So what that means is that the language model, as well as the user, can actually be aware of how to do things. And that's key. If you're going to ask the language model to solve a problem, you've got a case of, okay, to solve this problem, I'm going to need to apply this tool, followed by this tool. And conditionally, if this tool gives me this result, I'll need to do this, or I'll need to do that. If all that is in a template in the case, the tools have to be available for the language model to apply those steps. So everything is a note. The tools notes act as basically an interface. Yeah.
When you say notes and then, are you also taking into account the patient scans and stuff, or is it only the template?
So in this case, these are just me as a researcher notes. So it really is just a plain text with markdown.
So even if you have patient scan, it'll be, you'll be feeding it what the doctor thinks of it.
Again, really, it's personal. So we're really not really at this point getting into anything with regard to electronic health records. It's really just me. Think of I'm sitting in a classroom, right? So I kind of shifted gears maybe. So we were talking before about Clara, who is a doctor's assistant. This is just a researcher assistant. So
you're just sitting in the hospital room, but
I'm sitting at home or I'm sitting in a classroom. Yeah. So nothing to do with patients really.
Oh.
Only science.
Oh.
Yeah. So
no patients.
yeah, we like patients sometimes. Yeah. So, but we'll get back to them. So, so that I'm sorry if I blended those two different problems together. So now we're talking about it's really no different than if you sit in a classroom and you're taking notes on your tablet or on paper or however you take notes. That's the process we're talking about. So, and we're allowing a language model to look over your shoulder and help you do that better. So Obsidian is the note-taking application that I use and that this is integrated with. There's really no constraint. The only nice thing is that in Obsidian, all notes are plain text with markdown. It makes things a lot easier than using something like Notes in I think Microsoft. I think it's Notes. There is an executive, so this is the point of interface for you when you're talking to Moringa, which is voice, text. To talk about notes. So if you want to do something with your notes or want help with your notes. And then a case-based reasoning note folder, like I said, those are all also notes. So think of a case as a template for solving a problem. And then tools, which again, think of them as an interface point or interface specification for some function. So could be like an endpoint for making a call. So interfaces to all the agentic functions. So overall, this is kind of what we're talking about. So me, I'm the little stick figure up there making my notes, and I say somewhere in there that I have a problem, something I want to do. I want to do a search, or I want more information, and it so happens that there's a case that says if we follow these steps, we can achieve that. We can go do a search of a particular. For instance, I want to find out something about bioinformatics. There's a processing step I know I need to use to reach a particular analysis of some data I have. So it says, I know how to do that. I've got a case. So if you follow this step, if you go out and get this data, if you install these tools for your Python pipeline, so those cases exist. We can do a search to get those cases, but we also use the tools to actually achieve those cases. So the tools are what's being applied at each step to achieve some end, to solve some problem. The nice thing is it closes the loop in the sense that if I I have a problem and I solve it. And then sometime in a few months later, I have a similar problem. May not be exactly the same, but it is similar enough that if I were to do a search, semantic search, uh, it would come up with this similar case and say, this is awful similar to what you did last month. It looks like maybe we'll have to make some changes, but there's the ability to learn and to basically accumulate some sense of knowledge of how to solve problems in the cases. So results for this system are the application. So I'm sorry, when I say results, I'm going to show you basically an application of using this to a problem. So in this case, working group I work with in microbiology started with the observation that they had some sepsis patients that showed different temperature profiles that showed different survival characteristics. So some people with a higher standard deviation in the way their temperature behaved after they were admitted seemed to have worse outcomes. So that was the observation. So the hypothesis was, well, are there different temperature phenotypes? So is there something about the way temperature is moving and changing that would suggest maybe we can identify these patients ahead of time? I'm sorry, if we're gonna throat dries out. I don't want to talk this much. So are there different temperature phenotypes? So we iterate over different ways to test this hypothesis. And when I say we, this is me using, as I'm sure pretty much everybody in the room has used a language model to say, well, how would I go about finding temperature phenotypes? So my first instinct was I'll apply some frequency-based analysis. So anybody who's done signal analysis would be familiar with Fourier transforms or something like that. So that was my first thought. Okay. The language model said that sounds like a good idea, but have you considered using wavelets? Okay, well, I've used wavelets once or twice, but it's not something I'm that terribly familiar with. So again, there's this iterative kind of, well, how about we try this? We'll try that, write some code, and along the way, we're documenting the whole process that I'm going through to actually solve this problem, to kind of come up with a solution. And real world results, lo and behold, after doing some wavelet analysis and looking at the different features, each of the dots in this figure is a patient with sepsis, and the features of this frequency analysis seems to support the idea that there are indeed three different phenotypes of temperature behavior. And digging deeper into this, it turns out that it's not just that they're different. We can actually quantify how temperature is changing. Is it changing gradually? Because nice thing about wavelets, it's multi-frequency. So you can say, is it changing very gradually? Maybe in the response to being given Tylenol or something to lower your fever, or is it jumping around like this? Is that regular, or is it a lot of different change to it? So it turns out that these phenotypes capture that type of information and suggest that there are indeed different phenotypes. So next steps for Renga is to formalize the process. So the process I just showed you was a bit ad hoc. It wasn't always using the framework for Renga, but it was basically following the process and the framework that was being proposed to develop, as I mentioned, a case-based reasoning library so that abstraction can be applied from examples. So in other words, if I've done it before, can I use it to learn in the future? The idea that so much of what we do in problem solving is community-based, the idea that I'm probably not the first person to see this problem. Somebody else has probably actually solved this problem before. So wouldn't it be nice if we could learn from each other, maybe more efficiently? And then expand the tool set so that we have more ways of basically integrating the language model with this. And integrating it too, at the time that this was being done, reasoning models from OpenAI and others weren't available. So it'd be nice to be able to integrate that. And I'll conclude with a longer section on something that's much more speculative. but dear to my heart. So the motivating question here, so, and just as a warning, this is completely different than everything I've talked about so far. So reset. Can LLMs reveal the underlying metaphors steering scientific inquiry, and in doing so, help reframe problems, rebuild the scaffolding of inquiry, and accelerate discovery? So, to simplify that a little, whenever we're talking about problems of any sort, but especially in science, we have basically a scaffolding for how you think about the problem. A perfect example of that is in immunology. Do you think of immunology as a war, as a fight between your body and the invaders? Okay, that's a metaphor. It's a way of framing how you think about the problem. You could also think about immune response as a systems problem. Is your body trying to maintain stasis? Is it trying to maintain balance while other things are throwing the system out of balance? So although there's components of fighting, it's more really about how do you maintain a balance in a complex dynamic system. That's more of a controls theory kind of a problem. So those are all what I'm talking about when I'm talking about metaphors. How do we frame the questions that we talk about? So why does it matter? Well, LLMs are really good at language. They can analyze any problem with a view towards all of science just because everything's been fed in. So it seems like it's a nice way to leverage it. We have a chance to make hidden assumptions when we're making solving problems visible, things we don't even think about. Most people don't think always about why they're thinking of a problem as a conflict as opposed to a system. What's key to this study is intellectual leaps happen, and the idea is, could we make them happen quicker if we have a system that points these things out? So, famous diagram from Galileo, and the message here is that we shifted from geocentric, Earth-centric views to heliocentric views. That is an example of changing metaphors, and it's an example of basically measurement driving how we change our thought. So in this instance, if we really are geocentric, why is Mars moving backwards sometimes when you look up at the sky? And that was a problem. If you're in a geocentric world where everything should be spinning around, why is it going like this? So that led to different thinking, Copernicus and Galileo coming up with some of the thinking behind that. So that's what we're looking for. So how we think about and frame problems are the metaphors. It determines what is important to measure, and it determines how we make those measurements. And as I mentioned, it's the measurements and the data itself sometimes can also influence those. It does. And it guides how we interpret and model data. So how we think about problems changes and matures over time. So early on, one or two metaphors may dominate. So we may have a way of thinking about how the world works, or in this case, how planets revolve around something. But as more measurements are made and we have more data, it turns out that multiple metaphors may be applied to different aspects of the problem. And it may seem a little counterintuitive to start with. You think, well, maybe shouldn't we just be settling into one way of viewing things? But as you enrich problem space and you have more things to take into account, more data, it's common to have different metaphors for different parts of the problem. So this is all rather abstract, but the point is we can actually measure this, and we can measure it in the science that we do. So as a real example, here's sepsis 3 was basically a new way of looking at sepsis that came out in 2016, published. And it was the culmination of a lot of different ways of looking at sepsis. So sepsis is a life-threatening condition due to an infection, and basically a cascading effect that can be fatal. It is one of the leading causes of death in hospitals. So pre-2016, it was framed as an inflammatory storm. So again, this is the dominant metaphor that people are thinking about. So if you're having a storm, what's the component in the storm? The storm in this case is cytokines. The cytokines are just little messengers, molecular messengers throughout the body. So, but it turns out that when looking at that, it turns out that identical storms had radically different outcomes. So you could look at one cytokine storm or one storm that's going through the body in one patient, and this what seems to be the same storm in another patient, and one survives and one doesn't. So post 2016, this is grossly oversimplifying all the research that went into this, but generally it shifted from a storm metaphor to a system metaphor. So it was the way that the host, the patient, is responding, which emphasized networks, regulation, multi-organ interaction. So again, once you choose your metaphor, you want to measure different things because that's going to be what you use to explain. So getting a little more concrete. So I set up a list of different metaphors to search for, and they're grouped into families, dynamics, structure, ecology, conflict, and did a PubMed search for sepsis from, I think, about 2010 to 2020, both before and after that break point. So I have about 642 abstracts and 918 after. And then this is a plot of the metaphors as pulled out of all the abstracts. So it's a little messy, and you may not be able to draw any big conclusions from it, but we'll do another look at it in just a second. But what it shows is basically what the thinking is, or how people are expressing their thoughts about sepsis over time. So from 2010 out to 2021, going into these papers, you can see that there's a pretty good mix of different ways or things that are being expressed. A lot of them have to do with structure networks. A lot seem to have to do with storms and thresholds and control feedback. Some even have to do directly with warfare. Again, what we talk about as battle. But you see, there's a pretty good mix. So the question is there a signal here? Can we say that what led up to that shift in thinking in 2016 is something you can actually detect? And not only detect, could we predict it? So step back and think about, if I were to go into the literature in any scientific domain and say, here's what everybody's talking, here's how they're talking about it. And if I could look for something that's changing in the way they're talking about it, could I predict we're on the verge of maybe shifting how we think about things and how we frame problems and how we measure things? If we could do that, there's the potential there for accelerating how we do science. So that's the motivation for this kind of investigation. So this is another view of the same data. This is using Shannon's entropy to basically assess what's the mix of metaphors over time. So how much entropy, how much different stuff is mixed into each slice in time. And it's not too hard to see a trend here. It seems like we're starting at low entropy. Oops, sorry. And we're moving towards higher entropy. And in fact, I told you that the one thing I can do as a statistician is a t-test. So doing a t-test, it turns out that there is high significance. That's measuring the difference between entropy on that side of the line versus the left side between 2016. So going back to what I said before, it may seem at first a little counterintuitive that we have more entropy, we have more metaphors after 2016. But what that would be indicative of is that we have now a much more complex, nuanced view of what sepsis is. So as before, we were leaning heavily on things about control and storms and things like that, and energy. Afterwards, we're leaning on a lot more different things. And it's not because we have different ways of looking at the same thing, it's that we have a lot more things to look at. So in this corner of the problem, we may use a storm metaphor. In this corner of the problem, we may use something that's about stasis and balance. So that's a sign of maturity and of change through the way we're thinking about sepsis, about this scientific problem. And that's the question. Can we actually find the signal in other domains? Yeah.
Got how are we dealing with sepsis today with all these complex metaphors we have?
Well, if you think about the metaphor is really just how we talk about things. So
Yeah, how has that translated it?
not a physician, but my understanding is that sepsis care is improving. It's a very complex problem. And I've had doctors basically say to me that what we're looking at with sepsis is what we saw in cancer 10, 15 years ago, where everybody said there's cancer. And then it started to basically diverge, and we have this kind of cancer and this kind of cancer, but we have this family of cancers. So you're seeing something similar, you think in sepsis.
I feel like the issue with sepsis is that it's so, like, it happens so quickly that you've got to act.
Yes.
You
Yeah,
have time frame.
Yeah, and I came from oncology research before I came to U of M. And yeah, it's right. It's a lot, I'll say easier, but when you're in a problem space where things happen over the course of months and years, you've got time to study and to make decisions. In sepsis, like you just said, you're talking about, hours, maybe even minutes to make a decision that could mean the difference between somebody living or dying. So again, I think that's why I'm very interested in sepsis for a lot of my different things I'm doing in research. But I think it's fascinating to say, okay, we're talking about sepsis writ large here, but if we go into some of the smaller details about how cytokines are storms in some sense, but yet we want to look at the whole patient's balance. That would be interesting to see. Can we refine that through some of the ways we think about it and we discuss it? So that interests me. But yeah, it's a good question, good comparison. So this is very early on, and I'm encouraged to see that there seems to be evidence for a signal. The next thing, obviously, is to apply more domains. So take more examples beyond sepsis and say, okay, does this type of analysis seem to hold? Do we see these shifts? Do we see changes in entropy? Another aspect I didn't talk too much about, but was also done here, was not just metaphor, but measurement types. What is being measured? How is it being measured? That can also be part of the analysis. And then, as a typical machine learning type of approach, take all these examples, line them up, do some for training, some for test, and then validate it on a large sample, and include cases where there is no shift, null cases. So that's what's going on next. How can LLMs help in this instance? Because we're talking about language, they can certainly help in the quality of our metaphor and measurement detection. So reading through documents. We also have the opportunity to read through the method sections of papers. So not just the abstract, not just the summary, but actually dig down into the data, how it's being measured, how one paper's measurement differs from another paper's measurement. And then given the analysis of a domain over time, look for opportunities. And what I mean by opportunities is that use the language model as a language instrument of measure, look for mismatches between metaphor and measurement. So although we may be talking about shifting from storms to systems thinking, are we measuring things about system? What are we missing about systems that we could be measuring? And analyze that at a paper level and try and figure out how could we be doing this better? So that's an opportunity. That's an opportunity to accelerate the science. And then look for cues that would suggest other metaphors, which might show up as paradox. So back to Galileo and Copernicus. If Mars is moving retrograde, it's moving in the opposite direction. That's a paradox. That shouldn't happen. In my current thinking, everything's going this way. Why is it moving backwards? So look for things that are paradox and contradiction. So in summary, language is how we frame scientific problems. Shifts in tension in a domain's language often precede conceptual breakthroughs. And detecting these changes suggests a way to identify scientific opportunities and thereby accelerate discovery. There's a bunch of references for some of the stuff I talked about. To thank everybody I've been working with here at Michigan and at Wayne. Thank you. Yes.
Yes, can ask you to step back to Clara there for a moment.
Sure.
This is the program that will help a physician make a clinical decision, as I understand.
Assist at some level, yes.
Okay, assist, that's fine. Um, well, a physician, my understanding is practices against the background of an insurance program for malpractice. Now, if somebody or something wants to assist the physician in this process,
Mhm.
do they take on some of the responsibility for mistakes? Or do they not? I mean, does Clara have malpractice insurance? Let's put it that way.
You hit on one of the biggest things in clinical decision support. Uh, I'm not a lawyer, and I'm not up to date on all of it, but as I understand it, the physician cannot relinquish the responsibility. The physician is ultimately responsible, whether he's using stethoscope or a language model. And I think that's probably how we all want it too. We want a human that is ultimately responsible. I can't just say, well, the machine told me to do that. But
That's the question I'm asking.
yeah, and I
She
think
told me it's not my fault.
it's not my fault, the machine told me. And I mean, that drives a lot of what explainable AI is about. So it becomes not just machine told me, but the machine told me, and this is why it told me, this is how it reasoned about that. Again, I don't think it's so much that we want to relinquish responsibility or shift it to the automation machine as much as we want to have a better understanding of, well, you made that mistake. You know, why did you make that mistake? Why did the machine give you great confidence? So, but that the literature is, yeah, really floating in that area. So, but,
Flip side of that is, what if what if you didn't take Clara's advice? So is your
Yeah.
insurance overwritten by Clara? So the doctor didn't take Clara's advice, you're not getting paid.
is that malpractice, right?
Yeah,
Yeah.
that's where we're heading, right?
Well, that's the sticky wicket. Yeah, I mean, you've got two opinions, and one is a human, one is a machine, and if
And crowds are the two different doctors.
exactly, so yeah, so it's not a new problem in that sense, but it is one of responsibility. And like you said, it sounds really easy. The insurance company say, well, everybody who paid attention to Clara got it right, and you didn't pay attention to Clara, we're holding you responsible for not paying attention. So, yeah, is it different than reading a radiography radio report different or wrong?
I'm
Miss-
just on the pathology side.
Yeah.
That is a phenomenon where physicians are struggling to listen to the answers from models
Yeah,
on the diagnosis side.
yeah,
Like, it's just a thing that's happening where the program's coming back and saying, these are some scores associated with this particular set of
Yeah.
data you've given me.
if it's just a score and it's a black box and you as a professional who's seen thousands and thousands say, I disagree. I don't care if your confidence is 98%. I don't know why you're saying that. Yeah, then that seems like a good reason to not take the advice. But if we get to the explainability part where it says, well, the reason, because I can see, at this fine level, these details that you didn't notice, well, that's different. And if it can say that, if it can articulate the reason I'm saying that this is not what we expected, but is a rarer case, yeah. So, but yeah, no, that's no, and I mean, this is the famous one that's going around all the conferences now. You've probably heard is that I'll summarize it the best I can, but basically a system to assist a physician. So you had the physician do something and they achieved this accuracy. You had the physician plus the system use it and they achieved like a 2% better. You had the AI by itself and it was like 20% better. So no, so this is real data. I mean, so it's like, well, what's going on there? Why is a physician with a system that on its own would do a lot better, not doing better? And I think that's a surgery case. So I think there's a lot of investigation going on to what is the interplay between man and machine and confidence and all that. It's a difficult question, and we're being pushed into it because suddenly the machines seem to be a lot smarter than they were just a few years ago. So. Yes.
I'm very interested in that, and I have a question, like, if that's limited to file domain and they still to real time, like I'm sitting there and listen to this interesting seminar, can I take the money with it?
So, oh, you're talking about Renga?
Yeah.
Yeah, I haven't distributed it yet. It is not limited in any way to bio. In fact, it's designed to be flexible in terms of how you compose your tools and your cases. So I'm interested in biology as a domain, so that's what I use it for. But no, it can be doing searches in any domain. It could literature or philosophy or whatever. Yeah. So as soon as I have a distribution, I'll let everybody know. I'll get invited back. I could talk about it. Yeah.
Can I ask a question about Renga as well? And to go back to your sepsis example. I had at one point been diagnosed with being septic as well. Of course, it scares the devil out of you when you hear that.
Yeah.
But it turned out that the organism in question that had been pulled out of my blood was Staphylococcus epidermidis. That's an organism that resides on the skin generally.
Yeah.
And it's not found in the blood. In addition, I had been given a fairly heavy dose of a quinolone. And I asked whether this particular septic organism, so-called, was susceptible or resistant to the quinolone. And the answer was susceptible. And so I asked, well, how is it possible that a susceptible organism normally found on the skin is being treated as if it were a blood infection? And the answer that I got was, well, gee, I don't know, but we found it in the blood, so you must be septic. And so my question is, can Renga figure out a mistake like this, point it out, and withhold that data before it gets into one of your dot plots about what is or what ain't a metaphor?
So are you suggesting that what we had is not sense?
Yeah, I'm not sure what the solution is, much less could I solve it. I'm going to say in the second part, I probably couldn't solve it, but I'm not sure what, in an ideal world, what would the outcome have been? So they obviously cultured your blood, found something that they wouldn't normally find there, and it was there, and treated it.
Yeah, well, what I'm saying, this was an impossibility. Given the
Nothing's impossible, and as a microbiologist, I think, yeah, you probably know that. Yeah, no, you're right. It's like, okay, did somebody do the blood test wrong, or did you have a dirty needle or something that contaminated, or yeah.
I mean, if this Renga could point out a mistake, even point it out, never mind.
But my point is, what's the mistake? Yeah, I'm not even sure myself.
That would be a major.
Yeah, I think at this point, just to take a step back, so the bedside assistant, Clara, is really there as a walking bookcase more than anything at this stage. So it's not that the physician is going to ask a question that they don't know the answer to. It's more like, rather than go back to my desk and look this up, I'm going to ask the question here. And if I can get the question here, then it saves me walking down the hall and I can, serve the patient a little better. So that's where we're at with that. With regard to the note-taking systems like Renga and Limerick, those are just really what you make of them in terms of your own organizing. So clinically, I'm not sure I can address anything like that, because like I said, I'm not even sure what this proper solution is, regardless of what the system does.